Here I'm going to show you how to find the domain and the range of a rational function. And it's this one. We have 2x minus 1 over x squared minus 4x plus 3. So notice, we have a linear on the top and a quadratic on the bottom. Finding the domain is not so bad, but how would you find the range? We'll talk about that later. For the domain, it's always going to be whenever you have an expression on the bottom, you have to make sure we are not dividing by 0. So you just say x squared minus 4x plus 3, make it not equal to 0, and then solve it. We can factor it. We get x minus 1 times x minus 3 not equal to 0. So that means x minus 1 cannot be 0. X minus 3 cannot be 0 either. From here, x cannot be 1. From here, x cannot be 3. So as you can see, x can be any real numbers except for 1 and 3. To write the domain, we can use interval notation. We start with negative infinity, and we go up to 1. But we are not including the 1, so we put on parentheses, and then we have to get from 1 to 3. But I will put union in between them, because we put together with the next interval. Again, not including 1, and also not including 3. And lastly, we go from 3 to infinity. And you always use parentheses for infinities. So that will be for the domain. Now, how about for the range though? Let's take a look. For the range, it's actually a lot more difficult than the domain. Sometimes people will tell you, you will have to use a graphing calculator, graph the function, so you can see all the possible y values. Or sometimes people will tell you, you have to do some calculus in order to find the minimum, also the maximum. But here, for this one in particular, we have a linear over a quadratic. You can actually just do some algebra with this. And the truth is, as long as the top is degree 2 or less, and the bottom is degree 2 or less, you can always do the following method. Check this out. Firstly, the range is all the possible y values. F of x is the y, so we can just change that. And now here's the idea. If I say y is equal to 5, then I would like to know, can we find x so that this expression gives us 5? If that's the case, then we know 5 is in the range. Because this equation is solvable, we can actually get to 5. So the question becomes, we have to find for what y value so that this equation is solvable. And we want x to be real number only. So let's pretend y is just a general letter. We have to find out all the possible y values. What we are going to do is multiply both sides by this. So we have y times x squared minus 4x plus 3. That's equal to 2x minus 1. And then just distribute the y. So y x squared minus 4yx plus 3y is equal to 2x minus 1. And then I will make this side equal 0. So minus 2x, both sides, plus 1, both sides. And then we see we have y x squared. Both of them have x. I'm going to write it down like this. We add parentheses this term, negative 4y, and then minus 2, and then the x. And then plus 3y plus 1. That's equal to 0. Now, if you look at this equation, this is a quadratic equation in terms of x. And this is what I was mentioning. If you have a quadratic or linear on the top over a quadratic or linear on the bottom, this right here will always be a quadratic at this stage, and can use the following idea. Now, we have to make sure this quadratic equation actually has solutions, real solutions for x. How can we make that happen though? Well, the truth is we are going to use the discriminant. Here is the a in our quadratic formula, right? This is the b in our quadratic formula, and this is the c in our quadratic formula. But we just care about inside of the square root. Right here, we need, in order for this to have a real solution, b squared minus 4ac. This expression has to be non-negative, including the 0. That's the key. And then you can see that b squared is this, so that is negative 4y minus 2, and we will have to square that, and then minus 4ac. A is the y, and then c is 3y plus 1. And we have to make it non-negative. So now we have a inequality in terms of y, and that will tell us the condition for the y, and that will give us the range. So now let's multiply this out. You can just think about this as positive because you can factor out negative. Square that doesn't matter. So 4y squared is 16y squared, and then plus 2 times 4, which is 8, times that is 16. And then you have y, and then plus 2 squared, which is 4. And then distribute, we get minus 12y squared minus 4y. And we see this and that can be combined. That's 4y squared, and this and that is plus 12y, and then plus 4 is greater than or equal to 0. And notice everybody is divisible by 4, so we can divide everybody by 4. Positive 4, so you don't have to flip the inequality. So that's y squared plus 3y plus 1 greater than or equal to 0. Unfortunately, this is not factorable, but we can use the quadratic formula again. So we need negative b, which is 3, plus or minus square root of b squared minus 4ac. A is 1, c is 1, all over 2 times a. So y is going to be negative 3 plus or minus, that's 9, minus 4, which is 5 in the square root, over 2. These were the two zeros. And now what you can do is you can just draw a number line real quick. So this right here will be the one with the minus, negative 3 minus square root of 5 over 2. And then this right here is the one with the plus. And then I'm going to test out the solutions. Or in fact, you know this is a quadratic. If it's greater than or equal to 0, then it's open upward. So at 0, anything in between will be below 0. So this right here will give you a negative result, and then the two other ends will give you positive results. And you are including these two values because you are including the zeros. So now, we know that in order for this to be non-negative, we want everything from negative infinity to here. That will give us the first part of the range. Go from negative infinity to negative 3 minus square root of 5 over 2. Here, we are including the n value. Do not take the middle part though. We want the union, and then starting from this, negative 3 plus square root of 5 over 2, and we go all the way to infinity. That is how you can find the range for this kind of rational functions. That's it.